Hello students, today we're going to look at section 8.2, which is multiplying a polynomial by a monomial. Okay? Remember from yesterday, a polynomial is a series of monomials that are being added together, and a monomial is any variable, number, or the product of a number and a variable. So we have an example here, negative 3x squared times a quantity of 7x squared minus x plus 4. And we need to multiply these together. It's just distributive property, except now we have variables involved and exponents involved, so we have to remember our properties of exponents. So I'm just going to multiply the negative 3x squared times everything inside the parentheses. So negative 3x squared times 7x squared. The way we have to do this is first multiply the coefficients. So negative 3 times 7 is negative 21. And then x squared times x squared is x to the fourth. Because remember, when you multiply the same base, you add the exponents. And now I have negative 3x squared minus times negative x. So I know my answer is going to be positive, because negative times negative is positive. And then 3 times 1 is 3, and then x squared times x is x to the third. And now I have negative 3x squared times 4, and negative 3 times positive 4 is negative 12, and then I just bring the x squared because I have no other x's to multiply it by. So my answer is negative 21x to the fourth plus 3x to the third minus 12x squared. Again, it's just using the distributive property, but remembering to also use the laws of exponents, or the properties of exponents that we learned. In our next example, we have a couple of distributive property options that we have to take care of first. So I have 2p times the quantity of negative 4p squared plus 5p minus 5 times the quantity of 2p squared plus 20. So I have to do distributive property first, and then distributive property second, and then I can combine like terms. So let's take 2p times negative 4p squared. 2 times negative 4 is negative 8, and p times p squared is p to the third. And 2p times positive 5p is positive 10p squared. 2 times 5 is 10, p times p is p squared. Negative 5 times 2p squared is negative 10p squared. And negative 5 times 20 is negative 100. Now I combine like terms. I don't have any other p cubed, so it's negative 8p to the third. 10p squared minus 10p squared is nothing, so I don't even need to write it down. I don't do 10 minus 10 is 0p squared and just put p squared down. I don't do that at all, okay? And I don't do anything else except 10p squared minus 10p squared. Those are like terms, they're exactly the same, and the coefficients are exactly the same, and when I subtract them, it equals 0, so I don't write anything down. And then all I'm left with is minus 100 because I have nothing left to combine that with. So all of this simplifies to negative 8p cubed minus 100. For the next example, we're going to include more than one variable because that's always fun. So I have 15t times the quantity of 10y cubed t to the fifth plus 5y squared t minus 2y times the quantity of y t squared plus 4y squared. So I have to use the distributive property here, and I have to use the distributive property here, and then we're going to combine like terms. Okay? So I have 15t times 10 y to the third t to the fifth. Well, 15 times 10 is 150, and then t times all of this would be y to the third t to the sixth. Okay? Because I'm multiplying this t times all this, I have nothing else to multiply the y to the third by, so I just bring it down y to the third. And t times t to the fifth is t to the sixth, because 1 plus 5 is 6 for the exponents. Plus, 15 times 5 is 75, and then y squared t times t is y squared t squared. Now let's keep going. Negative 2y times yt squared would be negative 2y squared t squared. It's a negative times a positive, so it's a negative. Negative 2 times 1 is negative 2. Y times y is y squared, and I just bring down the t squared because it's times t squared. And then negative 2y times 4y squared. Negative 2 times 4 is negative 8, and then y times y squared is y cubed. And now I'm going to combine like terms, if I have any. Do I have any more y cubed t to the sixth? No, I don't. Now I have a y cubed over here, but it does not have a t to the sixth with it. So since they are not the same variable, same exponents, I cannot combine them. So I have to write down 150 y to the third t to the sixth. There are no other y to the third t to the sixth, so I can't do anything else. Now, I have a 75 y squared t squared and a minus 2 y squared t squared. Those are exactly the same variables with exactly the same exponents, so those are like terms. So when I have like terms, I just subtract the coefficients. So 75 minus 2 is 73 y squared t squared. When I'm adding and subtracting like terms, remember from yesterday, we do not change the terms variables. We only change the coefficient. And then the last one is minus 8y cubed because I have no other just plain y cubed. So minus 8y cubed. And there's my solution. 150y to the third t squared plus 73y squared t squared minus 8y cubed. The last thing we're going to do for this section is to solve an equation with polynomials on both sides. So I have d times the quantity of d plus 3 minus d times the quantity of d minus 4 equals 9d minus 16. First thing I have to do is distribute a property. D times d is d squared. D times 3 is positive 3d. So I have d squared plus 3d. Negative d times d is negative d squared. Negative d times negative 4 is positive 4d. And then 9d minus 16 because I can't do anything else with that yet. Now on the left-hand side, I have to combine like terms before I do anything else. I always want to combine like terms, make it easier on myself. So I have d squared minus d squared. That's 0. I don't write anything down. And then I have 3d plus 4d, that's 7d, equals 9d minus 16. Okay? Now you remember when we solved equations with variables on both sides, my suggestion was to start with the smallest variable. And I'm sticking with that suggestion. My smallest variable is 7d, so I'm going to subtract 7d from both sides. Minus 7d, and that leaves me 0 equals 2d minus 16. Now I need to move the 16 to the other side, because I need to get d by itself. So 2d equals 16. Because remember, magic happens when you cross the equal sign. When I take that negative 16 from one side and to the other, it becomes positive. So 2d equals 16. Divide both sides by 2. That means d equals 8. So I'm just taking what I've learned about distributive property, what I've learned about the properties of exponents, and using all of that information to solve an equation. One step at a time. Don't try to do too much at the same time. And don't try to talk and text and watch a movie and play a video game while you're doing your algebra homework, because if you do, you're going to miss a tiny little mistake, like a negative, and you're going to make a big mistake that ruins the whole problem, and then you're going to cry, and we don't want that to happen. So, concentrate. And here are the practice problems for this video. The first one, number 1, simplify. 2pr squared times the quantity of 2pr plus 5p squared r minus 15p. Use the distributive property, and if you have any like terms, combine them, but you won't. Number 2, negative 9g times the quantity of negative 2g plus g squared plus 3 times the quantity of g squared plus 4. Again, distributive property, but in this case, combine like terms if you have any. You will. So make sure you combine the like terms at the end. And number 3, equation. 7 times the quantity of t squared plus 5t minus 9 plus t equals t times the quantity of 7t minus 2 plus 13. Distributive property first. Combine like terms on each side first. Next, then subtract stuff from both sides to solve for your variable t. Take a picture of these practice problems and submit it through Edmodo, and let me know if you have any questions.